The expansion tank should be the highest point of a thermal fluid circuit. If this is not possible, other options like pressurizing the expansion tank could be explored. The bottom surface of the expansion tank shall be placed at least 1.5 meters above of the highest point of the circuit in order to produce some static pressure to the whole circuit. This static pressure is needed for the centrifugal pumps in order to provide them with a net positive suction head, NPSH, high enough to prevent cavitation. On the other hand, thermal fluid shall be preserved from oxygen contact in order to avoid the degradation of the fluid. Blanketing is one of the possible solutions to prevent such degradation. An inert gas, commonly nitrogen, can be used to make a blanket system. In order to prevent the expansion tank to become a pressure vessel, the design and operating pressures shall be inferior to 0.5 bar G, 1.5 bar A. Another advantage of this system is that the expansion tank will operate with an slightly pressure, 0.2 bar G to 0.3 bar G, that will increase the NPSH by 2 to 3 meter liquid column. In some cases, especially when the service temperature is higher than 350 degrees Celsius, 650 degrees Fahrenheit, a pressurized expansion tank is mandatory in order to avoid vaporization of thermal fluid. Through this system, the whole circuit is kept under static pressure high enough to allow the thermal fluid to work in liquid phase all the time. The vapor pressure of some fluids at 400 degrees Celsius, 750 degrees Fahrenheit can reach around 12 bar, so that a higher nitrogen pressure has to be kept in the expansion tank. This system also warranties that oxygen is removed from the expansion tank and therefore it avoids thermal degradation. Deaeration is a key point of the circuit. During startup, all moisture and humidity shall be removed from the thermal fluid. Double connection arrangement on the expansion tank helps to make it easier and faster during commissioning operations. Opening the bypass valve and closing the return valve during start, the whole fluid flow through the expansion tank, allowing deaeration to be more effective and faster. Once all the humidity and moisture have been removed from the circuit, the return valve shall be opened and the bypass valve closed in order to work in normal conditions.